Okay, this is activity 41 dash 1. Check your understanding. They ask you on part A to complete the table. So we put the totals in. We not only do we have cranes at this conservation place, but we also have flamingos. And there's two different kinds of flamingos. And of course, there's two different genders. So you can see the totals on the table. The probability of picking a male. So since they're not telling us which group we're picking from the total group. So over here you can see the probability of male. There are a total of 33 males, and it comes from right here. A total of 33 males, and there's a total of 60 flamingos. So 33 over 60 comes out to be 0.55. Then they want us to find the probability that you select a male given that it's a Chilean. Okay, so the probability of just this group right here. We know it's coming from this group. So the number that goes on bottom, see, right here is a 29. And the possibility that it's a male, there are 16 males. So 16 out of 29 divides out to be about 0.552. They must have rounded. This one says equal, so that means that must have divided out exactly to 0.55. This one says find the probability that it's Chilean given that it's male. So we're only picking from the males. So the total that goes on bottom is the total number of males. That's 33. So that's why we put 33 on bottom. And then of those 33 males, there's 16 of them. That's the desired event. So 16 out of 33 is about 0.485. It says round to the nearest thousandth. So that's why we're doing, that's 3 decimal places. You didn't know. Okay. And so now part C says, if a female flamingo is selected at random to the nearest thousandth, what is the probability that it is a greater flamingo? So let's see. We're only selecting from the females. So given that it's female, see, that's what they gave us first. This is the given information. What is the probability? And that's what we're wanting. This is the desired event, that it is a greater flamingo. So that's what they want us to find, the probability that it's greater given that it's female. So we're only looking at this group right here. We're only looking at females. So the number on bottom is 27 because there's only 27 females. And then the number that are greater is 14. So 14 over 27 is about 0.519. Okay, so that's the answer to check your understanding. Let's move on. They want us to do totals again. So I believe that's 21, that's 19, that's 26, and this is I can't add 14. Now, notice they did not give me a total column over here. I don't know if I'm going to need it, but I might. I might need to know the total number of less than 5, a total number of $5 or more, and a total number of kids. It says as part of their math course, Kate and Rob are required to do a statistical study. They selected a random 80 students from their school, so I know this number right here should be 80. And then you could get a total right here. Again, I don't know that I need that, but I might. So I'm going to go ahead and do it. So, less than $5, that's 23 plus 12, I think that's 35. Kids had less than 5 on them. And then 8 plus 9 plus 17 plus 11, that's 45. And you add that together and you do get 80. Okay, so that's the table. Now they want us find these probabilities, and so they want to find the probability that a student had $5 or more on them. So this is the desired event that they want us to go on top. But they don't want us to pick from all students. They just want us to pick from the 9th grade. So we're only looking at the 9th grade group. So the 9th grade, the total number of 9th graders that participated was 21. And the ones out of those 21, the ones that had $5 or more was 8. And if you do 8 divided by 21, you get to the nearest hundredths. To the nearest hundredth, that's 2 decimal places. So it's about 0.38. Okay. Find the probability of a student having $5 or more, not from the entire group, but just from the 10th grade. So I'm just using the 10th grade. We know that it's a 10th grader that they asked. So the total number of 10th graders goes on bottom. Given that it's 10th grade, that goes on bottom, and $5 or more, the number of students that had more than $5 or more, was 9 out of 19. I'm using my calculator. 9 divided by 19, rounded to 2 decimal places, is 0.47. And $5 or more, given that it's an 11th grader. Okay, so the total number of 11th graders was 26, and the number of students that had $5 or more out of the 11th grade was 17, and 17 divided by 26, rounded to 2 decimal places, is 0.65. And let's see, given that it was $5 or more from the 12th grade. So there's a total of 14 in the 12th grade, and 11 of them had more than $5. Did I do that right? 11 out of 14. Yeah. And rounded to 2 decimal places, that is 0.79. Since the sample was selected randomly, the students in the sample are likely to be representative of the school as a whole. That's kind of a rule for probabilities. Random is good. What do the answers to part B suggest to Kate and Rob about the amounts of money carried by students at the school? So it looks to me like, just looking real quickly, that your 11th and 12th graders are more likely to carry money more than $5. The 9th and 10th grade, that was less than half of them. On the 11th and 12th grade, more than half of them had it. So that would be the observation that I would make. So your upperclassmen tend to carry more money. Okay, here's a check your understanding. I'll go ahead and stop the video, and you can check your understanding of this, and at the beginning of the next video, we'll go over these answers.